Hello, my name is Megan Cabelli, and this is Lab 1, Charged Tapes. The purpose of this lab is to become familiar with the idea of charge on everyday objects and the interaction of charged objects. The problem is we wanted to determine how much excess charge is on one piece of charged clear tape. The result that I got was one piece of clear tape has an excess charge of 1.27 times 10 to the negative 7 coulombs. In this lab, I used a couple of different physics principles, and the first would be Coulomb's law. I also used the definition of an electric field. I used the formula for a force on a charged object. I used the formula for the force of gravity on an object, and I used the principle that same charges repel and opposite charges attract. For the first part of the experiment, I wanted to charge the tape. To do this, I started with a 20 centimeter base tape, and I put it sticky side down onto a desk. Then, with another 20 centimeter piece of tape, I stuck it almost all the way down onto the base tape and I left a small handle for grip. Then I quickly ripped the U-tape off of the base tape. I put the U-tape aside and I handled it as little as possible. And then after repeating steps 2 through 4, I had a total of 2 U-tapes. The second part of the experiment was testing the charge of the tape. So the first thing I did was I held my hand near one of the U-tapes, and I knew that if the tape moved towards my hand, then it had a charge. I then held the 2 U-tapes near each other, and I observed their interaction. I held a neutral object near one of the U-tapes, and I observed that interaction. And then I rubbed a pen on a cotton cloth to give the pen a negative charge, and then I held the pen near the U-tape to determine its charge. For the third part of the experiment, I wanted to determine the excess charge on the tape. So the first thing I did was I took the first U-tape and I attached it to 2 textbooks about the length of the tape apart. Then I took the second tape and I held it parallel to the first underneath it, and I brought it upwards closer to the first tape until the first tape began to float. When the second tape began to float, I recorded the distance that they were apart from each other. For this lab, I had to make a couple assumptions. The first was that each U-tape has the same net charge. The reason I could assume this is because I used the same method to charge the tapes, and so it's a fair assumption that both of them have the same charge. My second assumption was that I treated each U-tape as a single point charge instead of a long piece of tape with lots of different charges on it. I made a couple observations during this lab, and the first is that the U-tapes repelled from each other, which indicates that they are like charges. Secondly, the U-tapes were attracted to my negatively charged pen, which indicates that they are both positively charged. And third, the top tape began floating when the U-tapes were 2.7 centimeters apart. Here are my calculations. I started off by determining the force of gravity on one of the tapes. Because there was no movement in the y direction when one of the tapes was floating, I could assume that the entire force of gravity was being offset by the force from the charged tape. So I could use this force of gravity and I could input that into Coulomb's law. Also, using the assumption that both tapes had the same charge, I could turn Q1 and Q2 into Q squared, and then after rearranging Coulomb's law, I could solve for Q. I then used this value of Q to solve for the number of deficient electrons, and then using that value, I could solve for the fraction of atoms that gave up electrons. Here are my results. I determined that the excess charge on my tape was 1.24 times 10 to the negative 8 coulombs. The number of deficient electrons on my tape was 7.5 times 10 to the 10, and the ratio of deficient electrons to atom was 1 electron to 5 times 10 to the 6 atoms. Here are my glow script visualizations. On the left, you can see my code, including my function that I wrote to determine the charge on my tape. And then on the right side is the visual. The green arrow represents the force from the charged tapes. The purple arrow represents the force of gravity on the top tape. And then I have the tapes represented as point charges A and B. In this lab, there were 2 reflection questions. The first is, what if electrons had positive charge and protons had negative charge? What would change about the observation you made with your tapes and other charged objects? The answer to this is that nothing would change. The reason that the tapes had a charge is because when we ripped the 2 tapes apart, the electrons moved from one tape to the other. Even if electrons had a positive charge, the tapes would still end up having a charge, it might just be the opposite charge. But because I charged the tapes using the same method, the tapes would still have the same charge as each other, which means that they would still repel and one of the tapes would still float. The second question is, why is it important to handle the charged tape as little as possible? This is because charged tapes have an electron deficit, and if the tape were to interact with other objects, then there might be an electron transfer, and this would get rid of any charge that the tape had. All right, well, that is my lab 1. Thank you so much for watching, and I will see you for lab 2.